All right. So today we're going to talk about Ansible components. The first episode, we just talked about the use cases for Ansible. We talked about how we might use Ansible, what things we might use it for, modifying existing configuration or building new configurations, replacing them on the devices, sources of truth, that kind of thing. If there's any questions about the last class, I did put it up after it was posted. So you could watch the entire class. I cut out the first part, which was just me like futzing around trying to post the links and stuff. But this one will be about the components, the different components of Ansible. The one after this, the next class after this, I think I might just run it tomorrow at the same time. Initially I had it scheduled for Thursday, but I think I just might try to wrap this class up this week. The next one will be on Ansible variables, which is an important part of Ansible. But let's get to the components first. All right, first I want to check with the audience. How is the audio quality sounding? Everything sounding okay? If you could type in the chat room, just let me know. All right, we don't need this part. We're going to start out with a map. And a map is good for when you're lost. And if you're new to Ansible, it's easy to get lost. And what do you want when you're lost? You want a map. So this is the map. These are the different components of Ansible that we're going to talk about today. So first, we're going to talk about the Ansible control node. Then we're going to talk about the Ansible config file, the inventory file. We'll talk about playbooks. We'll talk about the controlled nodes. And we'll also talk about group vars and host vars a little bit. Those are variables, and we're going to get more into that in the next episode. So that'll be tomorrow probably. So the first part about Ansible, the aspect we're going to talk about is the control node. The control node is where we run Ansible from, and it's the only device that actually needs to have Ansible installed. It could be a bare metal system, it could be a virtual machine, it could be a container. It's almost always Linux. It doesn't have to be Linux. You could run Ansible on Windows. You could run it on native Windows. There's also Windows subsystem for Linux, WSL. But there are some caveats there. I've tried to run it. I've run into some issues, weird issues here and there. So I would just recommend running it on a Linux system. Just make yourself a Linux VM. Again, I've got the Autobox project, which is instructions to build out a Linux VM that has Ansible and a leaf spine topology running containerized EOS that you can practice all this on. Let me put this into the live stream chat. Thank you, Douglas. And so just make yourself a VM and install that. There's almost no reason to make it a bare metal system. It doesn't require that many resources. And it's almost always going to be a virtual machine. It's not always going to be a container. In fact, it's not usually a container. It can be. And the reason why we would make it a container would be if it was like part of a CI/CD pipeline. But containers are generally ephemeral, and an Ansible control node is usually persistent. It's usually around for a while. But it's almost always Linux. You can run it on BSD as well. You can run it on your like Mac laptop. You could run it on a free BSD system. But there's always like little quirks that you need to do that are extra that you might have a hard time finding some instructions for. So just run it on Linux is my recommendation. So the Ansible control node is often persistent, although sometimes ephemeral. So the difference, these are sysadmin terms. Persistent versus ephemeral. Persistent is what we typically think of a server as being, is it's always around. It's going to be around for a while. The lifespan is measured in years, typically for a virtual machine. Ephemerals means that it's meant to be created, used for a specific purpose in a short amount of time, and then it's destroyed, and none of the files are saved. So that might be with the CI/CD pipeline. but probably you're going to run it by itself and keep it running. So a virtual machine is usually the best platform for that. There are persistent containers, but I think it's just easier to run it on a VM. There's no HA, so Ansible doesn't run like a service. It's not running in the background. It's not running a runtime or a state machine. It's just a set of files that sometimes you execute. So there's no consistent running runtime or anything like that. So there's no need to HA it. There's no need to have multiples of them. Backups are usually handled by Git. So we don't, I mean, you can put it as part of your backup routine. You can back it up. A lot of virtual machine, a lot of VM infrastructures will have some sort of way to back things up. But you don't have to. Usually it's just in Git. So you can run your own private Git infrastructure. You don't have to use GitHub or GitLab, but those are two websites that are very handy and very commonly used for this purpose. Sizing the control node. Most of the time, Ansible control node is idle. So the thing that runs Ansible is just sitting there waiting for you to run a playbook. So it uses up very little memory, very little CPU, very little disk I/O. And even when we're running it, it can spike the CPUs for a little bit. It can spike the CPU a little bit, but it's not usually too bad. I usually don't do more than 8 virtual CPUs for a Linux control node, but you can do it that way. Yeah, so it depends on how many you have it running in some CPUs. Oh yeah, this is a get rid of that. That's a copy and paste problem there. So there's a lot of different ways we can install Ansible on a control node. So Douglas says that Ansible works well on Mac OS as well. We used it to manage AWS systems. Oh, okay, cool. I've always run into like little weird issues, and I mean they're not hard to get around, but I've just found it better to run it on a Linux system myself. But that's purely if you're comfortable with running it. Like there's people that love FreeBSD and they want to run BSD, and they want to do it that way. Then they can. So the best installing Ansible, there's a couple different ways we can install Ansible. The best way I know of is pip, which is the Python package installer. And I've got where's my demo here? Yep, there it is. So this is Alma Linux 9. I'm just going to do a quick install of Alma Linux. And I just made a quick VM. I'll show you what it's like to do an install. So we're just setting the root password. Create a user. Put in a terrible password. So if you ever do streaming, here's something to keep in mind. Don't use any passwords that you don't care about, or that you care about rather. So I use some bad passwords here because they're really simple, because apparently AI can listen to your keystrokes and guess your password. So if I'm streaming and publishing this, then that's a potential security problem. So I'm using bad passwords. So that, there we go. So Alma Linux is my favorite Linux distribution for this kind of thing, because I was used to CentOS Linux, and then Red Hat killed CentOS, and that was widely believed to be a bad choice. I'm still salty about that. And then we'll do a quick install of Ansible on top of that. It's super easy. It's barely an inconvenience. So that's what we're doing now, is doing a demo. And it's a pretty quick install of Alma Linux here. You can use whatever Linux you want. I just use Alma because in the US, at least, the enterprise Linux distribution of choice tends to be Red Hat. I think in Europe it's SUSE. So if you're going to pay for Linux, I generally don't find the need to pay for Linux. Excuse me. Yeah, I don't generally find any value in paying for Linux in most cases. If you're running something like Epic, which is a medical software, then yeah, if you're going to run something like that, then it's a good idea to run it. Um, but just Linux by itself, I mean, what's the point? It's almost always self-supported. If I'm running a platform that's Linux and then some other stuff on top of it, like back when OpenStack was all the rage about 10 years ago, that one kind of fell off a cliff. But Red Hat had their own OpenStack stack, and yeah, I'd pay for that because OpenStack is kind of a mess of all these spinning plates trying to interact with each other and all these different problems. So yeah, I'd absolutely pay for that. But since you agree, we migrated from CentOS to Ubuntu after that. Yeah, Ubuntu is a fine one too. I almost chose Ubuntu for this. I just stuck with a RHEL-like distribution because Alma Linux isn't completely RHEL-based, but it is very, very close. Like for our purposes, it's identical. There might be some kernel stuff that's a little bit different, with like slightly different kernel versions, but all the stuff that we do here is user space. All right, so writing network configuration. Yeah, so the next thing we're going to talk about is the Ansible config file. I actually don't really care much about Linux as an operating system. It's so because all the interesting stuff happens somewhere else. The only thing I want out of a Linux operating system is to be boring. All right, so I'm going to reboot this and log in. So Ubuntu and Alma are both operating Linux distributions that are great when you don't care about Linux, where you don't care about the operating system. Let's do a start. Boot this. I need to give it a reset. So I'm using Proxmox as the hypervisor because VMware, they recently got rid of the free ESXi, but I guess they reintroduced it. I'm not quite sure. Some people have been saying that they reintroduced the free version of ESXi, but it's too late. I've already switched over to Proxmox. All right, so we're gonna want to install. It's a little bit hard to read here. Can I do this? Yeah. So we're going to install pip3. A Python 3 pip. Oh, install. So Python comes installed with just about every Linux operating system, but pip, the Python package installer, is additional. And now we've got that installed. And now all we have to do to install Ansible is pip3 install Ansible. And that's it. So it downloads a couple of things that are related to it, a couple of other Python packages that it needs. How many resources did you assign for Alma Linux test VM? I generally will do at least 4 gigs. Although I don't think I need to do 4 gigs, but I've got a system that has 96 gigs of RAM, so 4 gigs not a big deal. You can probably get away with 2 gigs, no problem. And then you can just do 1 CPU. If you're going to do the auto box, I said 8 CPUs in 32 gigs, and that'll build you a leaf spine, or sorry, 16 gigs. And that'll build you a 16 gig VM with 8 vCPUs. Will build you a leaf spine topology box that you've got 2 spines, 4 leafs, 2 hosts, 1 router, and then Ansible, and then and then an IDE, which is VS Code running as a web app. So it's all in one. And you can run that in 16 gigs. I think it was 16 gigs and 8 virtual CPUs. That's all you need. But yeah, you can get away with not a lot with Ansible because it's just Python and it runs for like 30 seconds and that's it. So that's it. We just installed Ansible. So it's really easy to install. All right, back to the map. We talked about the control node. We talked about the sizing of the control node. We talked about how we deploy it. It's a single device, typically a virtual machine, typically running on a Linux VM. Could be running on Alma, could be running on Ubuntu, could be running on SUSE, whatever Linux distribution floats your boat. If you don't know, if you're not sure, start with the Autobox. So that was in the chat room. Let me post again. And the Autobox is basically, it's a place to start. One of the challenges that I think people face when they're starting out with network automation is they don't know where to start. They don't know what, okay, so install Linux. Which Linux? Okay, which Linux becomes, that could be a whole day thing trying to figure out which Linux you're going to use. And then, okay, so how do I install Ansible? Well, there's 5 different ways to install Ansible. Which way is the best? And how do I edit these files? Do I run it locally? Do I run VS Code on my desktop? Do I run Coder? So the instructions, the Autobox instruction just picks something. And it's the simplest installations I could possibly think of to make it. So it's just like 20 commands. And then you've got a fully fledged leaf spine topology, Ansible editor, all that is built into one VM. And there's other ways to do it. There are probably even better ways to do it. But that's the simplest, and it has everything you need in one place. So that's why I created the Autobox. Yeah. The only thing I contributed to the Autobox was just picking the methods and writing up the instructions. Any questions about the control node before we move on to the config file? So on the Ansible control node is a bunch of files that we need for Ansible to work. And the first one we're going to talk about is the config file. It's probably the simplest because it doesn't, I've got, in my case, this is the config file that I use almost all the time. So I don't make it any more complicated than that. It's typically in the root directory of Ansible. Now, actually, this is something I should talk about. Where to put files? Where do we put all these files? And so we could put everything in one place. So if we put everything in one place, we have a root directory, has Ansible config, inventory.yaml, playbooks directory, configs directory if we have that, host vars, group vars, templates directory, etc. So we put everything in one place. You could have Ansible config in Etsy, placed all around the Linux system. There's some default locations to find a lot of these files. I don't like to do it that way. I like to put everything in just one place. That makes it easy. That makes it more portable, so I could save it as a Git repo and then sync it with a GitHub, GitLab, or whatever, and then clone it or whatever I need to do with it. So everything's in one place. I don't like to have the files scattered out throughout the file system. So recommendation, put it all in one file, in one directory, one root directory. That's my recommendation. Yeah, Douglas says for experimenting on a Linux or Mac OS system, and if you need different versions of Python, which sometimes you do, like AVD requires a very recent version of Python. Running multiple versions of Python at the same time can get a little complicated. There's Python and variables, Python environments, and that's another reason why I recommend just if you're starting out, if you're new to Python, new to Linux administration, just make a dedicated VM for it, because that way you can just run the version of Python you need to run. You don't have to run simultaneous versions. There are solutions to run multiple Python versions, and they work, and they're not all that complicated, but it's just how many new things you get thrown at you at the same time. All right, so we're going to have everything in a single directory here. So the first file that we're going to look at is just the config file, and we'll go through these one by one. So in the Ansible config file, we have the option here: host key checking equals false. So if you try to log into a device for the first time, you've never logged into that before from whatever you're logging in from, there's a signature on that SSH server. Let me do a diagram here. So this is actually kind of an ongoing security problem that we have in the server administration world. SSH host key. So let's say I installed a new Linux VM, or any VM, but it could be, let's just do a Linux VM. And then I've got my laptop here. So that would be the screen there, and then I'll do a parallelogram. Where's my shapes? Look at that, got a neat little laptop here. So join those. So then I go in, the first time I log into that VM, I don't know that VM from a can of paint. I don't know anything about it. And what will happen is you will get an error message, as you should, and it'll look like this. So I'm going to log into Leaf 46. It says, warning, permanently added Leaf 46 to the known list of hosts. And it's because I've never connected to it before. I don't know, because I've never connected to it, I haven't established an identity. There could be a man in the middle. So there could be someone intercepting my SSH connections. And then scraping all my passwords. I have no way of knowing. Now, on my home network, it's unlikely that that's happening. And if it does, it's not probably a problem because it's just, these are labs. But there needs to be in a proper world, there needs to be a key. There needs to be a way to distribute this key that was created on this Linux VM, some sideband method to get it onto my desktop so that when I do SSH, it validates that key. So in a lab environment, I set host key checking to false. If Ansible goes in via SSH and it doesn't, and the SSH client says, hey, I've never seen the system before, by default, the playbook will stop. That's probably the behavior you want in production, but we're in a lab environment, so we're going to turn this off. So we're going to set that to false. So that's what we're doing here. So we're telling Ansible, don't worry that you've never connected to this before. Don't worry that you don't recognize this. Just keep going. So in a production environment, you may not want to do that, but you'll need to have some way of getting those SSH host keys onto your devices, and not a lot of places have anything in place to do that. So something to keep in mind. Next is, where do we find our inventory file? We just say our local directory inventory.yaml. It could be another file. You can call it something else, but we're just calling it inventory.yaml. This is Jinja 2 extensions. You generally don't need this for your normal Ansible installation, but I use something called AVD, Arista Validated Designs, and it requires that, so that's why that's there. And the next one is gathering equals explicit. So when by default, when you run Ansible, do I have the Ansible logo up here somewhere? I can copy and paste this. So by default, when you run Ansible against a device, it will run something called gather facts. And gather facts is just tell me about yourself. And it runs this by default. You don't have to set this. And these facts are just basic, like what's your operating system, what's your file systems look like. Just very basic stuff about the server itself. These are server-oriented facts. We don't care about them. So we don't need them. It doesn't hurt to collect them, but there's just nothing useful we can do with them. Let me show you what that looks like. So I've got. Let me clean this up a little bit. So admin at leaf 1. All right, so in the playbook, it would look like so do demo 1, simple Ansible. So there is a GitHub repo for this particular class. So let me post that into the chat room. I'll be updating it after this class. So there is like the single add VLAN. So this is a very simple playbook. You'll often see a playbook that looks like this. You'll often see this in a lot of playbooks. And we don't need this. If we, in the Ansible config file, because I always put this in the Ansible config file, I say gathering explicit. That just makes me able to tidy up my playbooks. Because that basically is the same thing as this, but system-wide. And again, most of the time, there's no reason to gather any facts about any of these devices. There's nothing really we can do about it. I'm getting some errors. Oh yeah, I need to install Ansible in just a second. All right. So what we can do, I can gather facts. So let's do some gather facts. Display facts. So I'm going to make a playbook here, and I'm going to call this gather and display some system facts, just to see what kind of stuff we get. So host, let's just do it on leaf 1. And we're going to do gather facts equals yes. This is going to override the default, which is set in the Ansible config file, which is explicit. Explicit means I have to tell the playbook to do it. Implicit is the default, which means it's always going to do it unless you tell it not to. So display fact, and then we'll have tasks, and then we'll have name. The first task is going to be gather facts, or I don't know. Yeah, display facts. There's a built-in module. What is light speed? I don't know what that is. Ansible light speed. Yeah, I don't care. So Ansible built-in debug, and it'll be message. I think it's facts. Yeah. Let's see what it does. Why does it not like that? Oh, true. It wants a Boolean. I think it works with both, but the linter wants a Boolean. Okay, it says task includes an option undefined variable facts. Oh yeah, so what is the gather facts? I'm gonna look this up in another screen here. Ansible facts. There we go. So this is just all the information we get from the system. And there's not a lot here. And Ansible is not really good at taking information and making a decision, so we're just going to ignore it. Tip this over here. Sorry about that. Let's go to tip a light over. Okay, so we're just not going to bother with it. So we're not going to gather facts, and in the Ansible config, we'll do it there. Okay. So that's what gathering facts does, and that's the config file. That's it. So not much to it. The next is what we're going to be spending the rest of this time, for the most part, talking about, which is the Ansible inventory file. So that's probably where you want to spend some thought when you're designing your system, is how we're going to arrange everything in our inventory file. The Ansible inventory has groups and hosts. Now, Ansible is kind of inconsistent in how they name things, because in a lot of the documentation, you'll see Ansible control node and Ansible controlled nodes. So those are the devices that we're running Ansible against. And in the actual inventory file, it doesn't refer to them as nodes. It refers to them as hosts. I've even tried, can I just say can I say nodes instead of hosts? And no, you cannot. It has to be a host here. So we call them hosts. So you might see documentation refer to the devices that Ansible controls as nodes, but for the most part, we're going to call them hosts. So there's groups. We group, for example, here we have hosts leaf 1 through 4. We group them into a group called leafs. And then we can have subgroups, like leafs and spines are a part of a subgroup called our fabric. And they're all under the group called all. We can also put variables in the inventory. I generally don't like to put variables in the inventory file unless they are related to credentials and how we connect to devices. So these are variables that we set, and they're set for all of the devices because they're under the all group. So these are variables for all. And this just sets the username, password. Again, in the episode 1, we talked about how we don't normally put passwords in plain text in inventory files or playbooks. Instead, we'll put them in something like Ansible Vault or some other secure means. So for a lab, we're just keeping it as simple as possible, so we put it in there. But we wouldn't do that in production, of course. How we connect, which is some of the options that we have to figure out when we're doing automation of network devices. But these kind of variables I will put into the inventory file, but I try to keep everything else out when I can. And the file format, there's actually a couple different file formats that we can use for the inventory file. We could do the old school INI, so that's an old school Linux style. It looks very much like the inventory file config. So this is the INI style right here. So it's just a something and then equals and then something else. We can do it in YAML, which is what the recommended method is. We can even do it in JSON. I think there's a couple others that are supported. But we're going to do it in YAML. If you do it in the INI style, it seems simpler at first, but gets really complicated really quickly. And YAML seems to be the best fit, I think. I don't like to do JSON manually. I don't like to edit JSON manually. YAML is much better to edit manually. So all hosts and nodes need to be declared in the inventory file. So whatever we're controlling through Ansible, if Ansible doesn't see it in the inventory file, Ansible is not doing anything with it. It's a good idea to group related hosts together in Ansible groups. You don't have to organize your hosts into groups, but it really makes a lot of sense to do so. And then a host can be in more than one group at a time. So here's an example of a group. So we're going to put everything, we've got let's say we got 3 spines and 4 leaves, and we just put everything into the all group. And you can do it that way. And then some simple installations that may be just fine. So let's make a new demo directory. Call this Ansible components demo. And I'll put that, display fact. I'm going to move that into the demo. Ansible components demo. So this is demo 4. I'll copy the inventory file, put it in there. And we'll copy the Ansible config file and put it in there as well. Actually, for the inventory file, we're just going to create it from scratch. So this environment that you're seeing, this is the Autobox. So this is VS Code running on that Linux system as a web app, which is really handy. So I can just run everything from here. So I'm going to create a new file called inventory.yaml. Now, YAML files traditionally will start with 3 dashes. They don't have to start with 3 dashes. That's a convention, but it's a good idea to do it. It just tells everyone that this is a YAML file. We're going to do an all key, and that's going to be our all group. And then for all, I can put hosts, and I can do leaf 1, leaf 2, leaf 3, leaf 4, spine 1, spine 2, spine 3, and I'm done. That's it. We've told Ansible about the devices, and now I can run playbooks against these devices. So I could go to display fact. Let me rename this to facts. It's kind of bugging me there. And if I try to do Ansible playbook, display fact, it didn't do anything because wasn't able to log into it because we didn't give it any credentials. So if I want to be able to log in, I'm going to need some credentials. So I'm going to steal them from here. I'm going to put this stuff in. So now these variables, these Ansible variables, will be applied to all these devices because it's under all. So let's do that again. Oh, that's right. I turned off display facts. So yeah, gather facts. True. And there we go. So I was able to gather facts there. So that's a working inventory file. All the hosts are in one group. Now, let's say I wanted to get smarter and I wanted to separate them out by spines and leaves, because there may be certain things I want to do to leaves and certain other things that I want to do to spines. So I'm going to create children, and then I'll create a group called leaves and a group called spines. Spines. And to give you a diagram of what that looks like, so I've got spines and I've got leaves. So I'm going to separate them out. Now they're all going to still be in the all group, but they'll be in their own subgroups. So now I've got spines and I got leaves, and then under each one I need a section called hosts. And then I just copy and paste them. And in the editor, a really handy shortcut is Control right bracket, and then I can indent or dedent. You know, if you've never done this before, this is kind of a game changer because in YAML, we are indenting and dedenting quite a bit. So I can go back and forth. And then under spines, I'll just use that host. And then there we go. Now I've got two groups, spines and leaves. I can also create other. I don't have to make my devices monogamous to a group. They can be in other groups. So in this case, I'm going to create two other groups called maintenance A and maintenance B. So maybe I want to run some maintenance scripts on my odd number devices because I have them in MLAG pairs. I've got them redundant so that I do my odd number devices first. And then I can do, when that all checks out, I can do my even number devices. So maintenance group A and maintenance group B, pretty common tactic. So let's go ahead and set that up. So call it maintenance A, host, leaf 1, leaf 3, spine 1, spine 3, and then maintenance B, leaf 2, leaf 4, spine 2. And I can do it that way. So it really just matters. It's just what makes sense in your environment. How would you what's a good way to organize this stuff? And there's more than one right answer. But the basics are that we have an all group, and then we have children, and then our children can have children as well. So let's say I've got in my project nerd here. Yeah, here's the photo. There we go. I actually have host 1, host 2, and R1. They're not part of the fabric, but maybe I do want to do some stuff with them. So I'm going to make another group. Actually, I'm going to do two subgroups. So I'm going to have a group called infrastructure and a group called fabric. And then fabric will have children, and then that'll be my leaf, spines, and maintenance groups. So just indent them until they go under there. And then I'll also have infra, and I'll just do hosts, R1, host 1, host 2. Or I could do infra children, so I can have some groups underneath of that, and I'll have hosts as a group, and routers. So hosts, host 1, host 2. I might run into a problem with that being named the same thing. And routers, hosts, R1. Let's see if it complains about it. Nope, we're good. So I can make several different layers of groups. It really just depends on what makes sense in your situation. And I think this makes sense. One more thing we can do is we don't have to list out every host. We could do this. 1 through 2, host 1 through 2. We can do leaf 1:4, 1 through 4. And then spine 1 through 3. That saves a lot of lines and makes things simpler. Another one for the maintenance A, I could also do leaf 1 through 4, count by 2. So 1 and 3. And then for spines, I could do spine 1 through 3, count by 2. And that would just be spine 1 and 3. And then for leaf 2 and 4, I can do leaf 1 through 4, or count, I'm sorry, leaf 2 through 4, count by 2. So that'll be 2 and then 4. And then just spine 2 because there's only one device. One other thing about the hosts is, I'll put this in here, put this in the slides, is hosts and DNS. So every host normally should be in either DNS or hosts have to have some kind of IP address. And we could do it a couple of ways. We could do DNS, so a DNS entry. We could do etc hosts. In Windows, it's C Windows System 32 drivers etc hosts. I think that's where it's located. But in Linux systems and Unix systems in general, it's etc hosts. So that's actually what we have here. So in Container Lab, we generally don't use DNS. We just put it into the host file. Or we need Ansible host. So we could, even if it's not in DNS, even if it's not in etc hosts, we could say Ansible host is 192.168.1.11. Something like that. Or is Ansible host? I think that's what it is. Let's try it. Where's demo 4? Let's try it against R1. Let's see what we get. Yep, that's what it was. Ansible host. Now, if we do it that way, then I can't do the, R1 through 5 because that won't work. But I try not to do Ansible host. I try to at least have it in etc hosts. In production, it'll probably just be in DNS. But we have to be able to resolve the host name to an IP address somehow. And those are the three options, at least the three that I can remember. So DNS, etc host, or Ansible host. Any questions? Okay, so I think that's it. We need to talk about playbooks. I'm sorry, inventory file. Next, we're going to talk about playbooks. So what is a playbook? A playbook is a YAML file containing one or more plays. A play is a set of tasks to be run against one or more hosts. A task calls upon a module. A module has the code necessary to perform a specific task. A module will require parameters, and parameters necessary to complete a task will vary from module to module. So for example, if we're adding VLANs, what do we need and what parameters we need? Probably the VLAN name and VLAN ID. If we're adding a L3 interface, we need to know the IP address on it, the IPv4 address, IPv6 address, or if we're going to do a routing protocol on it, like OSPF, and what area, those kind of things. So here's the anatomy of a playbook. This is a simple playbook, which is going to add a VLAN. And it has one play. A playbook is a YAML file. So it generally will start with 3 dashes. And then it has a list of plays. The first one here, we only have one play. You can have multiple plays, but we only have one play. And we're going to add VLANs to device. The host is leafs. So we can put either a host in for the hosts, like leaf 1, leaf 2, leaf 3. We can put them in comma delimited format, leaf 1, comma, leaf 2, comma, leaf 3. Or we can specify a group. That's probably the best way to do it, is just to specify a group. But you could do, or you do a combination. You can do multiple groups. You can do hosts and groups, all separated by commas. And then we, every play will have tasks. So you need to have at least the name and the host. And then we have a section, we have a list of tasks. So we have one task in this case, and it's calling upon a module. The module is arista.eos, EOS underscore VLANs. This is the fully qualified name of this module. I could get really lazy and I could cut out this first part. But at some point, Ansible started complaining. I could just say EOS VLANs, but Ansible started complaining and said, you know what, just go ahead and not do that. So we do the fully qualified domain name now, or not domain name, but fully qualified module name. So arista.eos is the Arista EOS namespace. There's multiple modules in there. There's about 20 or so, 30 or so. And one of them is EOS VLANs. And then under it, we need the parameters, the config and the state. And those parameters are going to differ from module to module. Obviously, in VLANs, we're going to need the VLAN ID. And the state is going to be active, and the state is merged. State here, we see state twice. It's kind of confusing. Name VLAN 100, VLAN ID 100, state is active. So that means that VLAN, particular VLAN, is active. Otherwise, we could suspend the VLAN. And then the other one is state merged. So that's for all of the VLANs that we add, because we can add more than one VLAN in here. The state is merged, which means we're merging with the existing VLAN database. We're not overwriting it. So if there's already VLANs there, you want merged so we don't delete those VLANs. Here we have two plays. So one playbook, but we have two plays. And the reason why we're differentiating the plays is that the first play we're running against the leaves. The second play we're running against the spines. So that would be a reason why you would have two different plays if you were running a different set of tasks against different sets of devices. In this case, we're doing VLAN 100 for the leaves and VLAN 200 for the spines. I don't know why we would do it that way, but I needed an example. And then we could just do multiple tasks in a single play. So here we have one play, but we have two different tasks. We also could have just done a list of VLANs here. I didn't even need to do multiple tasks, but yeah, we can do it this way. Any questions? Now, at some point, your plays in your playbooks might get pretty complicated, and an advanced topic we're not going to talk about in this episode is something called Ansible, spaced out on it. And we're not going to create a module. We're going to create a. I hate when that happens. Having a senior moment here. Roles. We'll have an Ansible role. A role is a way to take a bunch of plays and playbooks and put them together and hide them. Essentially, not really hide them, but just present them as a single role. So you just call a role, and then it does all this stuff in the background. But we're not going to get into that in this class. So one thing I will do now, so take a moment and do a episode 2, commit 1. And then push that. Am I on? No, I need this one, publish branch. Oh, I'm not logged in. Oh, I'll do that later then. Okay. Um, yeah, loops. We could also do loops. We're not going to talk too much about loops. We can loop through a playbook. So loop through items from a variable, but the variables we're going to get into the next episode. So we're going to spend more time talking about loops in the next episode. Okay. Any questions about inventory files or configuration files? So I have to for this system, I have to log into GitHub so I can publish to my my repo. But all of these files that I've created for this particular episode will be in the GitHub repo. All right. So what we're gonna finish off the class today's episode with, I'm gonna schedule the next episode for tomorrow at the same time, 10 a.m. and we'll talk about variables. And that's our we're going to finish off today talking about the nodes themselves, how we connect to the nodes. So Ansible was originally meant to be used with servers. That's what it was created for, was to do configuration management. So let's say you created 100, well, take a step back. So Michael DeHaan was the creator of Ansible. Now it's maintained by many people, but he was the creator of it, and I think he's still involved. And he was the creator of Cobbler, which was a automation for installation of Linux systems on bare metal. So let's say you had racks and racks of servers and you wanted to get Linux onto each one of them. Well, what do you do? Well, you could use Cobbler. It would install Linux on each one of those devices automatically through automation. It's like power on provisioning or ZTP. So zero touch provisioning. So you turn them on, they'd net boot, they'd install themselves. And he needed a way to configure them after that. He needed a way to be able to push web server configs, web applications, database configs, SQL, all that stuff. He needed to be able to push that. So that's what he created Ansible to do. And one of the things that he realized that the other systems like Puppet was probably one of the most popular systems to do something like that. But it was closed source or partially closed source, and it cost money over a certain amount. It was so he wanted to create something free, and he wanted to make sure that it didn't require an agent. So that was another thing. So Puppet required an agent at the time. So he set it up so that all Ansible would need to be installed on was the control node. The Ansible would SSH to a device, copy over Python code, and then execute the Python code locally on that system and then delete it when it was done. So that way it could go in and configure SSH. It could configure, well, SSH is already configured. It could configure things like Apache servers, Spark servers, MySQL, MariaDB, Postgres. It could configure all these different servers and give them the right configs and all that. But with network devices, we don't log in via SSH to execute code. So that's not a way that we get into these devices. A lot of these network operating systems don't even have Python installed. Some of them do, like Arista does, but a lot of them don't. So instead, there's different ways to connect to a network device. The way that we connect to these network devices really depends on the device, and different devices will have different options. Different network operating systems will have different options. Even in the same vendor, like Cisco has like a dozen different network operating systems. They've got iOS, iOS XR, iOS XE, NXOS, ACI, and then they've got controllers. What ACI is a controller. They've got DNA Center, which is now Catalyst Center, which is a whole thing. So there's different options for each one of those. But generally you can boil it down to one of three, I think. One is the vendor specific APIs. And honestly, those are the easiest ones I've found to deal with. Because they're not trying to abstract anything like the open APIs do. Open APIs has an extra layer of abstraction, which can complicate things with like Yang models, and it's kind of a mess. But vendor-specific APIs are pretty easy to work with. There's Cisco NX API for NXOS. There's Arista's eAPI. These are both RPCs. One is JSON-based. One is XML-based. I think you can guess which one is which. They're really easy to work with. And when I'm going into EOS, for example, I try to use the eAPI. But with EOS, I also have the option of going in via NetMiko, just going in via SSH and then making modifications to the config, just like I was an interactive user. So we might call this screen scraping, but this is far more advanced form of screen scraping. And then other devices just have like netconf or resconf, and it really depends on the device. And we can take a look in the documentation. Try to find the documentation here. There is connecting, because each device has like, platform options. So all these are all the different platforms, and they all have different ways to connect. So for EOS, for example, we can go in via the CLI, so that's NetMiko screen scraping, or we can go in via eAPI. For NXOS, we can go in via the NX API or the CLI. For we can go in via netconf and most things. Juniper, they've got netconf in the CLI. iOS is just the CLI because iOS doesn't have any. iOS is a monolithic, old school, 90s based monolithic kernel. Not very flexible. But iOS XR is a little bit more flexible. They've got netconf and so EOS. There's Dell OS 10. You can go only the CLI. So there's different ways to connect depending on the device. There's only actually, is that it? Yeah, there's just NX API. Or EOS X, Exos. I don't even know what that is. Exos API. Yeah, so there's different ways, and it really depends on the network operating system, what method you pick. So we can go in via NetMiko. I used to not be a big fan of screen scraping, but NetMiko, it's a library, Python library created by guy does the free Python class by Chuck. Where's that guy? Chuck Byers. Kirk Byers, sorry. I was thinking Chuck. I don't know why I thought Chuck. Kirk Byers. So you got Kirk Byers, and he's got he's got a I think he still maintains NetMiko. Does he still maintain NetMiko? Kirk Byers, NetMiko. Did he maintain it? Yeah, he was a creator for it and still one of the maintainers, I think. Anyway, so that has SSH. It's got a translator so that I want to do this, and then it knows what CLI commands to go in for the config. So NetMiko. So all those work. And NetMiko goes in by SSH, but instead of going into the file system and uploading Python code, it's just manipulating the config files. Because like we talked about in the last class, most network devices are single configuration file devices. So what we would think of like running config for Cisco, Arista has the same concept, running config. Juniper has the same concept, but they call it something else, and I can't remember what Juniper calls it. And we're just modifying that config, or replacing that config, and we can go in via any of these methods to do this. There's something rare, so I'm going to end the class with this. There's something rare you can do. You can treat some network operating systems like a server. So for example, Arista EOS, you can run Ansible against it like it was a Linux server, because Arista EOS is a Linux server. It is running, now it is running Alma Linux. So that's what Arista EOS is based off of. It's Alma Linux. It formerly ran CentOS, and before that Fedora. NXOS is also Linux based, and it's based off of some weird Linux distro from like 15 years ago. but they don't expose the Linux underpinnings, but Arista does. So we could actually go in. Where's my... Yeah, so I'm going to log into... Oh, yeah, let me finish this up real quick. Oh, never mind. So if I go to admin at leaf 3, I'm going to bash, and then I can say cat etc release, OS release. And I can see this is Alma Linux 9.3. So I can Python 3 version. So maybe I want to install some like Python scripts or something other, something very, some of the network operating systems, most of them you can't do this, but Arista EOS you can, and some of the others. You can actually install stuff. Like I could install an IRC server on EOS. I could install a Doom server on EOS if I wanted to play network Doom. And you could do it through Ansible, treating it just like a Linux server. I created Arista's automation courses. And the first version that we did like 5 years ago, 2020 or 2019, somewhere around there, we actually had this in the course. We would teach you how to do that. But no one really did. Maybe 10 years ago, 15 years ago, we thought we might be doing automation inside the network operating systems themselves. But we generally have figured out that it's much better to do it off the box. So do it on like an Ansible control node and have that do automation, or Nornir or something else. It doesn't have to be Ansible. So yeah, we don't really do it that often, and I'm not even going to really cover it in this course because it's pretty rare, but that's an option that you have. All right, so it's just about 15 after the hour. Are there any questions? So we got about the same number of watchers last time. This video will be posted just like the last one. So this will be episode 2. This was on Ansible components. The first episode was the introduction to Ansible, why we would use it, why we wouldn't use it, the different ways we can use Ansible. And the next episode is going to be on Ansible variables, which is very important in some of the more advanced use cases for Ansible, like doing loops and doing Jinja. And yeah, so the fourth class will be Jinja. So any questions in the chat room? If you do have any questions and you want to have them answered, I can do like a Q&A. So you can send me an email. I have one set up for this. TonyTheAutomator@gmail.com. So if you think of a question and you want it answered, I'll do a question and answer the next time, at the end or at the beginning, and we'll do that. All right. So if there's no questions, I'll go ahead and stop the feed. I want to thank everyone who watched for watching. And if you're watching this after the live event, I'm going to keep these videos up forever. And just as a free resource to learn Ansible for network automation, automating network configurations with Ansible. And hope you enjoyed. Thank you for watching.